Welcome back. Well, I just got back from a conference in Nashville, Tennessee, and while I was there, you know, those conferences, they give out little baubles and trinkets and things, and one of the things they gave out is this thing right here. It's a little light-up, lightsaber-y thing. So let me hit the button, and you can see it blinks different lights. Let's turn off some lights, maybe you can see it better. Yep, so it's got blue here, red here, and green there, and it blinks in different patterns. And as you press the button, it does different chase effects and whatnot. Interesting. So I was really curious to see how it worked, and I had a thought or idea of how it probably worked. I figured, let's take it apart and figure that out. So I'm going to make a guess as to how this works. So I think it has. I bet you it has one or two little coin cell batteries running at about 3 volts. It's got a single 8-pin microcontroller of some kind. It's got some resistors for the LEDs. And the microcontroller has one of the pins is tied to a button input. And a couple of the pins are probably tied to the LEDs. And I'll bet you that those LEDs are, you probably have one wire or one pin per LED to drive the LEDs directly off the microcontroller. But I have a feeling, though, it might be Charlie plexed, which I'll talk to you about what Charlie plexing is if you don't know what that is. And the reason I feel that is because when you look at the slow pattern, you can kind of see how, here, turn that back off. You can kind of see how it like drives red independently of green, and green and blue are on at the same time, which indicates that they're on opposed pairs or something like that. And that's kind of how Charlie plexing works. So let's take it apart and find out. So I might need a screwdriver, but this end, this is where the battery is, the battery and the controller and everything, and you can unscrew this and get the battery out if you want. Right here. And there they are. Yeah, just little coin cell batteries. So we'll just go ahead and put the screw back in there because we don't want the batteries to fly all over the place. Okay, so let's take this out. So the first thing, first, it's got a little plastic plug in here that you can kind of just fish out of the end. That little plug comes out. You can kind of see down the end that there's really just like there's a string of LEDs down the middle of it, and that's basically all there is to that. So let's go ahead and rip this out of this end here, and it's just kind of hot glued in place on the one end, and the wires just string down the middle of it, and that's all there is to it. Press the button to turn it on and go through the sequences. Yep. So let's take a look at this and see if I was correct about the configuration. So what do we got in here? We've got, let me get a pointy tool. This will help see it a bit better. So we got the battery leads, which come over from the sides here, and this is going to be our negative side because this bare wire here is probably our common or ground or 0 volts. This is going to be our positive side. Yep, there's a positive connecting through the switch here that then goes in here, and we have one pin going to the microcontroller. It's kind of a chip on board or blob on board type of thing, just a bare chip underneath here. And then we've got multiple pins here. We've got this pin here, which, if I flip it over and look at it, doesn't seem to be tied to anything. It's just kind of floating in there. I wonder if we could tie something to that to get that to do something. Huh, that'd be nifty. And then we basically have our common ground and 2 signal lines. And by looking at that, that kind of does indicate that it is Charlie plexed. Usually what you would need if you're not Charlie plexing something is you would have a common ground, and then you would have a signal line for each LED. We have 3 LEDs, 1, 2, 3, but only 2 signal lines. So this definitely is Charlie plexed. How does that work exactly? Let's draw this out real quick and see if we can figure this out. So basically what we have is we got a 0 volt rail coming down like this, right? And then we've got a, I would call it a signal A and a signal B. Signal A and signal B line. And so what we have is, if we look at this long line here, yes. So this wire here, over here, we'll call this signal B. Yes, so signal B comes out of the microcontroller like this, and effectively what you have is you've got your LED coming out like this. So that's one LED. I believe that's the green one. So it has its own line, but then what you have is you have a single signal line coming out of the microcontroller going, if you look, this one, oh, well, the ground came off, so it's dead now. This one goes to the positive, or the short end of the LED, which is negative. And if you go up here to the other one it goes up to, it's going up to the short end as well. So in reality, it's not actually Charlie plexed. It's they basically just share a line. So that what that means is you have the A line that comes like this, and it's like that. So those are your LEDs. This one's red, this one's blue. So what that's saying is that blue and red are on at the same time, then green is on by itself, and they flip back and forth like that. Now they could have Charlie plexed this by doing something like the 0 volt ground rail, and then an A, and then having a signal on, or having one LED go this way, and one LED go the other direction. And this actually is just A and B, and they've reversed the polarity on these, so you can use 2 wires to drive 2 LEDs. And they could have done that here, but it wasn't really necessary. The circuit isn't terribly complex, but that allows you to use 2 wires to drive 2 LEDs instead of having 3 wires to drive 2 LEDs. You can look up Charlie plexing and research that. And I really thought that's what this is, but it's not really. All it is that basically these two guys, the red and blue, are just attached straight together. This is the long lead, that's the long lead, this is the short lead, and that's the short lead. Yep. And then this guy's all by his lonesome. And when you look at it too, the way this is done, this is actually, because these are going to the long leads of all of the LEDs, this that I thought was the ground is actually the positive line, and it's using the microcontroller to sync that current instead of source it. So yeah, interesting. Well, that was just a quick little doodad I wanted to take apart and show you. I thought it would be nifty to get into this little electronic device and kind of show you how these things are wired up and how they function. Hope you enjoyed the video. While you're here, like, subscribe, and do all the YouTube-y stuff. It really helps the channel out. In addition, if you really like my channel content, look at the link in the description to go to Patreon. Drop $1 in the cup to help me out and help keep my museum stocked, and help me keep putting things on my bench to take apart and show you. And while you're here, check out some of my other videos, and remember, 8 bits are all you need.